Hi everyone. In today's session, we will see eigenvalues and eigenvectors. So there are four category of problems in this eigenvalues and eigenvectors. We will see the first part over here. What is a characteristic equation and characteristic polynomial is the basic definition that we need before moving into eigenvalues and eigenvectors. Characteristic equation. What do you mean by characteristic equation is when I am able to write determinant of a minus lambda I equal to 0, this is called as the characteristic equation of capital A. Now, characteristic polynomial, when this determinant, when expanded, will give a polynomial which is called the characteristic polynomial of capital A. Now, the working rule to find out the characteristic equation for 2 by 2 matrix, let A be a 2 by 2 matrix, then its characteristic equation is lambda squared minus s1 lambda plus s2 equal to 0, where the s1 is sum of main diagonal elements. That is, I have to add up a11 plus a22. And s2 is determinant of A. That is the A matrix. When I apply the determinant concept, when I expand the determinant, I will get a numerical value, which is how I get s2. For 3 by 3 matrix, the working rule is the same with the s1, s2, but the characteristic equation will differ. It is lambda cube minus s1 lambda squared plus s2 lambda minus s3 equal to 0, where s1 is the sum of main diagonal elements and s2 is the sum of minors of the main diagonal elements. So how to find out the minors is a11 is the first diagonal element. I have to leave the corresponding row and column. So I have to write a22, a23, a32, a33 plus the next diagonal element is a22. I have to leave the corresponding row and column. So I will get a11, a13, a31, a33 plus the next diagonal element is a33. I have to fix up. I have to leave the corresponding row and column. So I get a11, a12, a21, a22. Now S3 is nothing but determinant of A. So when I expand it, I will get a numerical value. So we have to go back to the basic formula of characteristic equation. I have to substitute S1, S2, S3. I will get an equation. Now, if A is a null square matrix of order 2, then what is its characteristic equation? Just a question to put forth. So lambda squared will be equal to 0. Eigenvalues and eigenvectors of matrix. Let A be a square matrix. The roots of the characteristic equation are called the eigenvalues of capital A. Whenever I put A minus lambda equal to 0, I will get an equation. When I find out the values, when I find out the answer for that characteristic equation, it is called as the eigenvalues of capital A. Now, if there exists a scalar lambda and a non-zero column vector capital X such that Ax equal to lambda x, then lambda is called the eigenvalue of capital A and X is called the eigenvector of capital A. That is, lambda is a scalar and x is the vector. When I'm able to write in the form of ax equal to lambda x, then lambda is called the eigenvalue and x is called the eigenvector of capital A. Now, what is a working rule to find the eigenvalues and eigenvectors? Find the characteristic equation determinant of a minus lambda equal to 0. Solving the characteristic equation, we get the characteristic roots. So this characteristic roots is called the eigenvalues. Now, to find out the eigenvectors to each different value of lambda, that is to each different value of, that we get by solving the characteristic equation, we have to solve a minus lambda into x equal to 0. Now, these are the four different categories as I told you earlier. Non-symmetric matrices with non-repeated eigenvalues, symmetric matrices with non-repeated eigenvalues, and non-symmetric matrices with repeated eigenvalues. The last type is symmetric matrices with repeated eigenvalues. The very first step we will see now. So non-symmetric matrices with non-repeated eigenvalues. Find the eigenvalues and eigenvectors of 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. So by this time you should be able to identify whether the given matrix is symmetric or non-symmetric. So when you just observe the first row, it is 11 minus 4 minus 7. What is given in the first column is 11, 7, 10. So the elements does not match. So we say this matrix is a non-symmetric matrix. So the question is find the eigenvalues and eigenvectors is the question. So let me take the given matrix as A. My very first job is I have to find out the characteristic equation. So to find out the characteristic equation, S1 is sum of main diagonal elements. So S1 is equal to 3 and S2 is sum of minors of diagonal elements. So sum of minors of diagonal elements means the same thing which I explained here. 11 I have to fix up. I have to leave the corresponding row and column. So I get minus 2, minus 5, minus 4, minus 6 plus The next diagonal element is minus 2. I have to leave the corresponding row and column. So I get 11 minus 7, 10 minus 6. Plus the last element I have to fix up. So I get 11 minus 4, 7 minus 2. When I expand the determinant, I get S2 value as 2. Now S3 is determinant of A. So determinant of A as usual, when I expand along the first row, I get 11 times minus 2 minus 5, minus 4 minus 6, minus of minus 4 times. I have to leave the corresponding row and column. So I get 7 minus 5, 10 minus 6, plus minus 7 times 7 minus 2, 10 minus 6. So this when expanded, I will get the S3 value as 0. Uh, so the characteristic equation is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. When I substitute S1, S2, S3 value, I get the characteristic equation as lambda cube minus 3 lambda squared plus 2 lambda equal to 0. So to find the eigenvalues, I have to take a lambda. So this is the next step I have to do to find the eigenvalues. So when I observe the equation, I'm having a lambda in common. So let me take a lambda common outside. So I get lambda squared minus 3 lambda plus 2 equal to 0. So lambda equal to 0. And this is lambda squared minus 3 lambda plus 2 equal to 0. So I get lambda equal to 1, 2. So what are the eigenvalues? So the eigenvalues are 0, 1, 2. So but at this stage you have to check whether the eigenvalues are repeated or not repeated. So obviously when I observe these are distinct eigenvalues because all three values are different. Next, I have to find out eigenvector. To eigenvector, that is a minus lambda I into x equal to 0. In this, I have to put lambda is 0. So I get ax equal to 0. A is the given matrix and x is the vector x1, x2, x3. Now to solve this, I have to select the last two rows I have to select. Just observe how we are doing. Last two rows. When I take the last two rows, x1, when I write x1, below x1, I should not write x1 values. See, imagine this is x1, this is x2 and this is x3. Okay. So x1 by minus 2, minus 5, minus 4, minus 6 and x2 divided by minus 5, minus 6 is already there. I should not write x2. So I have to write 7, 10 and x3 divided by. So when I write x3, already 7, 10 is there. I should not write x3 value. So I have to write minus 2, minus 4. Just by cross multiplication of these, I will get the next x1 by 12 minus 20, x2 by minus 50 plus 42 and x3 by minus 28 plus 20. When I simplify, I get x1 value as 1, 1, 1. This is the first eigenvector x1. For the eigenvalue lambda equal to 0. Next lambda equal to 1 is the next eigenvalue. So when I put lambda as 1, I get 10 minus 4 minus 7, 7 minus 3 minus 5, 10 minus 4 minus 7 times x1, x2, x3 equal to 0. So x1, x2, x3 the same way as I explained earlier, you have to choose the last two rows. So when I simplify this, I get x2 value as 1 minus 1, 2. Next, third case is lambda equal to 2. When I put lambda equal to 2, I get the matrix as 9 minus 4 minus 7, 7 minus 4 minus 5, 10 minus 4 minus 8 times x1, x2, x3. When I select the last two rows and simplify by the same method, I get the x3 value as 2, 1, 2. So these are the three eigenvectors corresponding to the eigenvalues 0, 1, 2. So this is how we find out eigenvalue and eigenvector of for a non-symmetric matrix with non-repeated eigenvalues. Thank you.